drawn.
All right, so you should have a blank sheet of paper to be able to draw your diagram of the Earth's atmosphere's layers. So if you could right now, go ahead and on the left-hand side, write "Trust me" on the exam. Pay attention to what letters are capital and which ones are lowercase. You're going to want to do the same on your diagram. At the bottom of your diagram, I need you to draw out a curve representing the surface of the Earth. On the right-hand side, I want you to at least draw one line going down the middle over here to separate where you're going to put information about the temperature as you're going up in altitude and the air pressure of each of these layers. I'm going to pause just for a second so that you can get your "Trust me" on the exam written on the left-hand side, so that you can get the curvature of the Earth down at the bottom, and so that you can get your line drawn for temperature and air pressure. What are the first two letters in "Trust me" on the exam? All right. What did we read was the first layer closest to the Earth? All right, so go ahead and draw that in. Circle your TR, write troposphere. Draw you a little line going across, or curved line going around the Earth. It is 16 kilometers or 9 miles high. It's everything from down here on the ground all the way up to 16 kilometers or all the way up to 9 miles. Think about the mountains that we have on Earth. If you were to look at the tops of most mountains, I would say, what do you sometimes see at the top? Snow and ice, right? So that tells you that the top of the mountains is what kind of temperature? Really cold, right? If you can think about that, it'll help you to figure out the temperatures and how they change for each of the layers. If you can figure out what the starting point is. Okay, so when you're looking at the mountaintops, it gets colder as you go up into the troposphere. So you're going to start here at the Earth's surface where it's warmer, and as you climb higher into the troposphere, it's going to get colder. So draw you an arrow pointing down. This means that as you climb into the troposphere, the air gets cooler. They also told us that this is where all weather occurs in the troposphere. So I drew a little cloud symbolizing that all weather occurs here. The next two letters that are capital are ST. And the way I remember this is that trust is very important to everyone. And so trust actually has two of our layers in it, troposphere and what is this one? Stratosphere. All right, stratosphere. Strato actually means layer. So stratosphere is in between 16 kilometers and 50 kilometers. It's between 9 miles and 31 miles up into the air above our Earth. And the stratosphere has a layer of ozone. So they call it the stratosphere for a reason. It has a layer, a protective layer for us. Unfortunately, there is a large hole that is being created over the continent of Antarctica. But we do have a lot of ozone left that is trying to protect us from those ultraviolet rays. All right, O3 is the chemical equation or the chemical composition of what ozone actually is. It's actually 3 atoms of oxygen glued together or stuck together. And oxygen usually likes to be stuck together with just another buddy, so just 2. And so this is why it's so easy for the ozone to be broken apart, because it's highly reactive. It wants to react to whatever bounces around it. So if any chemicals and stuff gets sent up there, released up there beside the O3, that extra third oxygen is going to want to jump off and join whatever is next to it. All right. With the ozone layer being there, it traps heat, which is also called the greenhouse effect. So we let in a lot of ultraviolet rays from the sun, and the ozone layer keeps it there. And that's why the stratosphere increases temperature as you travel up from the 16 kilometers, it's cooler, until you get up to the 50 kilometers where it's the warmest. Jets fly in the stratosphere. We have heard that the jet stream is normally located in the stratosphere. At times it may dip down into the troposphere. So be careful in the end of the year exam and pay attention to whether they're talking about the temperature increasing with altitude or decreasing with altitude. And that'll help you figure out if they're talking about the jet stream being in the stratosphere or the troposphere. All right. Everybody should have already labeled the troposphere and the stratosphere at this point. The next layer we have is the mesosphere. The mesosphere is located between 50 and 90 kilometers, between 31 and 55 miles up into the air. This is where meteorites burn up. This is where we have radio signals that get bounced back to Earth so that we can listen to radio. This is also the coldest layer, which is why I've put an ice cube up here. And being that it is the coldest layer, temperature is going to decrease as you go up into space. The next layer it mentions in our article is the thermosphere. Now, your article doesn't state this, but the thermosphere is actually this last layer that goes up, and it actually contains two other layers. And so that is why I am doing this diagram for you so that you can have the correct information. It did mention some, but it didn't mention everything you need to know. The thermosphere, thermo, we know means heat. So the thermosphere is actually the hottest layer of the atmosphere. And if you see where I have written thermosphere here, the thermosphere is actually both of these layers combined. Okay. The reason why is because the temperature actually increases from this 90 kilometers all the way out into space. Okay. So let's talk about what those other two layers are. There's a kind of like a division line right here at 300 kilometers up or 186 miles. And just between the mesosphere and that line is a layer called the ionosphere. And I know it's not mentioned in your diagram, but the ionosphere is made of little particles that are positively and negatively charged. They're called ions. You may have heard about that in science last year. But those ions are the very reason that we have that light show called the Northern Lights or the Aurora Borealis. And so it's important to note that the ions that are there, and because of the magnetic field at our north and our south pole, we are able to see this beautiful light show called the Northern Lights. All right. Up above the ionosphere, which is also still part of the thermosphere, you have the exosphere. Exo meaning leaving. So this is the last layer that leaves out into outer space. And it's kind of like a blended line. You don't really have a set line that's the edge here. It's just kind of like, if you imagine, it just kind of like blends right on in here. There's not really a defining line for the exosphere. The exosphere is where all of our satellites orbit our Earth. All right, so at this time, if you need to pause this video to make sure that you've got all of your layers and labels and arrows and distance, whatever you need to do, go ahead and mark everything that you need to have on your diagram.